Yeah. Anyway, now this problem here, the problem I run into with it is I've got multiple signs happening. And remember, the ultimate goal of this is to kind of treat the trig function itself as some kind of variable to be solved for. You want to be on the lookout for any time that you can factor. And as a subgroup of factoring, you also want to be on the lookout for perfect squares. Those are going to pop up as well, not necessarily on this problem, but kind of be aware of how that might happen. So as a quick analogy, in case I'm not seeing this comfortably right now, if I were to write this problem down this way, 2y squared plus y minus 1, we can look at that and go, okay, I can factor that. That gets factored into 2y minus 1, y plus 1. Yeah. Right. So if that's the case, then what I can do is say, all right, let's go back and take the sign, do the same thing. I'm going to factor this as 2 sine x minus 1 and sine x plus 1. And those multiply together to give me 0.
I get it.
Which now, yeah, so what am I going to do from here then?
Then you set both of them equal to 0.
Bingo.
Bingo.
2 sine x minus 1 is 0, or sine of x plus 1 is 0.
Bingo.
And now I can now this is stuff we started with, where I've got a single trig function that I'm solving for. So this is going to give me sine x is equal to 1/2, which means x is an inverse sine, for emphasis, of positive 1/2. And then I go to my unit circle and think about that. Sine is my y values. Y is 1/2 at pi sixths, isn't it?
Pi sixths and pi plus.
Yeah, pi sixths. And 5 pi sixths would be the other place it happens because sine's positive. So 5 pi sixths. Now for emphasis, this problem says, and I didn't write at the top, I want to say I want my interval to be between 0 and 2 pi, non-inclusive. So that means I'm just going to look at one lap. I don't need to write the equations out for this fella. If I were to write them out, then what I would be doing here is taking this 2 pi 6 and multiplying that out by an additional 2 pi n, 5 pi 6 by 2 pi n, et cetera, et cetera. Let's see, now if I continue the thought here, sine x plus 1 means I'm looking at sine x is equal to a negative 1. X is an inverse sine of negative 1. Why is negative 1 right here?
Because it's rho. And that's why.
That's at the point 0, negative 1. And that's going to happen at 3 pi halves. Now, technically, what you should do with most of these is go back and double check it. I'm a little tight on space, so I'm not going to work out the check for this problem. But you do want to kind of make sure that you haven't introduced any extraneous answers, because it will happen. And especially if you square both sides. That's when you really got to watch for extra answers.
How would you get rho?
If I were to plug in pi sixths up here, does it work out? Do I get something that does cancel all the way down to 0, or do I get something else? Same, or do I get like undefined? Same thing with 5 pi 6, and same things with 3 pi halves.
Wait, so should we do that with this one?
Would you plug in the x and then just put it all in the calculator?
That would be the easiest fix. Basically, so my check for this, let's say I want to check pi sixths. 2 sine of pi sixths squared plus sine of pi sixths minus 1. Does that, oops, ran out of space, does that equal 0? And then you check to see if that does indeed work out to be 0.
Does it?
Yeah, actually it will. All of the answers we have listed here will check out. So pi 6, 5 pi 6, and 3 pi halves all our solutions. Most of that work, though, comes from this idea going back here and seeing that I can factor this and then use that zero product property from algebra 1 to break it into smaller equations and then take them from there.
Is that what that's called?
This right here is called the zero product property.
It's called the factor.
Yeah. Of course, where it gets kind of fun is once we split it, if it's not a one sub, if we have to do other fun stuff to finish it.
Yay.
Well, fun to me.